We are looking at R.D. Sharma solution, class 11, chapter 22, Cartesian system of rectangular coordinates, exercises 22.2. First question is, find the locus of a point equidistant from the point 2, 4 and the y-axis. So one point is 2, 4, and because y-axis is there, on the y-axis x is 0. So one is 0 and one other will be, we take always hk, and since it is equidistant from these two and we are talking about y-axis, it has to be k. It has to be k. So we have to have a point which is having a distance from these two equidistant. The distance has to be equal. So let us take a point P. Say we have a point P. So this, the 2, 4 is one point A, the second point is 0k, and we assume the point P to be hk. Why we have taken k? Because whenever we are talking about y-axis, x is 0 and that y value will be equal to the point which is equidistant, right? So we have, now we have use the distance formula. So it will be 2 minus h whole square plus 4 minus k whole square equals this 0 minus h whole square and k minus k whole square, and you can square PA and PB, and so that you get rid of the under root, square root. So PA equals PB, PA square equals PB square, and this will be the equation. Take off the root and just rearrange it. Finally you will have k square minus 8k minus 4h plus 20. So you have to replace this h as x and k as y. H as x and k as y. So this is your locus, a point which is equidistant from these two, 2, 4 and 0k. Find the equation of the locus of the point which moves such that the ratio of its distance from 2, 0 and 1, 3 is 5 by 4. So there is a point, and its distance from 2, 0 and its distance from 1, 3. So let us take this as point P, and this is as P as A and PB. So we have this distance, say D1, this is distance as D2. So D1 by D2 has to be equal to 5 by 4. 5 by 4. So let us say it is hk, P is hk. So distance formula we are going to apply. H minus 2 whole square plus k minus 0 whole square, the above one, and h minus 1 whole square and k minus 3 whole square, the below one. So this equals 5 by 4. Now you can just square both sides so that you remove the root, square root. This is 5 by 4. So I am going to square it. When you square it, you are going to get h minus 2 whole square plus k square by h minus 1 whole square plus k square minus 3 whole, k minus 3 whole square, k minus 3 whole square equals 25 by 16. Now you just need to rearrange. You know how to open the square formula. So just take left hand side, right hand side, combine the like term. Finally you will get 9h. Finally h and k will be replaced by h by x and this by k. So you are going to get this equation, which is the final equation. A point moves as so that the difference of its distance from AE, 0 and minus AE, 0 is 2a, and prove that the equation to its locus is x square by a square minus y square by b square equals 1, where b square equals a square into e square minus 1. So this is an equation of a conic section. We will talk about the hyperbola, parabola and ellipse later, but this is a kind of a conic section. So we take the point as hk, and this is moving such that the distance from AE, 0 and the distance from minus AE, 0, the distance and the difference of the distance, say it is d1 and this is d2, so d1 minus d2 equals 2a. So whenever we see we just have to use the, first of all, take d2 on the right hand side. Why? Because it will be easier to solve. We won't be able to solve root and root in a very good way. So just take the d1, ae minus h whole square, and 0 minus k whole square. This is the first one. Then 2a, then minus ae minus h whole square, and 0 minus k whole square. You know already the distance formula. And now you just have to take the square. You have to take the square. Otherwise, if you take d1 plus d2, that will be very difficult, cumbersome to solve. So you take one d distance on the right hand side. So we take this square, take the a plus b whole square formula, right? And then we will try to take the like terms. And finally, we'll take all the terms on the left hand side and we'll leave root on the other side. Then again we'll do the square. I'm saying that after rearranging, the right hand side square root has to be eliminated also. So there is a position when we try to rearrange, the solution is in front of you. Finally you will get this one. See, this is h square by a square minus k square by a square into e square minus 1 equals 1. H square by a square minus k square by a square e square minus 1. Finally this is what you are going to arrive at. So in the question it is already given b square equals a square and bracket e square minus 1. So you have to put what? In this place you have to put b square. So h square by a square minus k square by b square equals 1. So this is all the rearrangement in front of you. So this is the final locus of the given condition. Find the locus of a point such that the sum of its distances from 0 to and 0 minus 2 is 6. So again we have to use the distance, but here now we have to add just like previous question, but here we are going to add d1 plus d2 equals 6. So 2 points are 0, 2 and 0 minus 2. 2 points are 0, 2 and 0 minus 2. So let us take a point P and we always take it as HK. There is one point 0, 2 A and there is a point B 0 minus 2 and the distance, this is say d1 and this is distance d2 and d1 plus d2 is given as 6. It is given as 6. So let us use the distance formula. We already know h minus 0 whole square plus k minus of 2k plus 2 whole square, and then this second distance also h minus 0 whole square plus k minus 2 whole square. And now you have to take the one of the root on the right hand side. Otherwise I am telling you it's very difficult to solve it, because if you square these two terms, use the formula of square, one square will be eliminated, but you will get 2 into 2 square root. So better to take one on the right hand side, and now it will be easier. It will be far easier than the previous one. And finally you will get 9x square plus 5y square equals 45. Finally we have to replace h by x and k by y. Now find the locus of a point which is equidistant from 1, 3 and x-axis. So same question we have already done. So point is equidistant from 1, 3. So x-axis we are talking about, y will be 0. So we are taking h and k always. So this one part, when we are trying to find out h, the h will be same. So this will be h0. 1, 3 is one point and h, 0 is the other point. Now we will take the distance. So PA, PB. So h, let us take the distance and square them. You get h minus 1 whole square and k minus 3 whole square, and 1 minus h whole square or 3 minus k whole square you can take equals h minus h whole square and 0 minus k whole square. Both will be h. And when we Put it here, rearrange this, and finally replace h and k. You will get x square minus 2x minus 6y plus 10 equals 0. Next one is find the locus of a point which moves such that its distance from the origin is 3 times the distance from the x-axis. So again we have a point. Now the locus of a point which moves such that its distance from the origin, so 0 0 from distance from 0 0 is 3 times its distance from the x-axis. So say this is x-axis. You know, on x-axis what will be there? X-axis, y will be 0. And what this will be? We were talking about, we have already seen h and 0. So h and 0. So this, the distance, this, say this is say d1, d2. So d1 equals 3 into d2. So what is d1? d1 is h minus 0 whole square, k minus 0 whole square. So h square plus k square. What is here? Distance is h minus h0 whole square, k minus 0 whole square. So only k square will come. So it will be 3k square. Now we'll square them. See, this is h square plus k square under root. Now we'll square them. So only h square and k square will remain on the left hand side, and on the right hand side you will get 9k square. 9k square, because we have squared it. 3 3 9, and this is k square. So under root 9k square will come. So h square plus k square equals 9k square. So when we rearrange it, h square equals 8k square, that is x square equals 8y square, replacing h and k with x and y. So final x square equals 8y square is going to come. Next one is A and B. There are 2 points, phi 3 and B 3 comma minus 2. These are 2 fixed points. Find the equation to the locus of a point P which moves so that the area of a triangle PAB is 9 units. Area. So area triangle PAB is 9 units. So now we have 2 points. Basically we have vertex or vertices, 2 vertices of a triangle. Third vertices will take it as HK. So for one is your phi 3, the other is your 3 minus 2. Now this is H comma K. Now we take the say area. Now we know the formula of area. The area is 9 units. So what is the formula of the area? Half into x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2 equals 9. And please remember, it's a modulus sign. So this is x1 xy1, this is x2 y2, and this is x3 y3. Now whenever just replace this value x1 y1 x1 x2 x3 and y1 y2 y3, replace this value. Now whenever we replace, we'll get a final equation. Now the area can be positive or a negative. I'm not saying the area will be negative, I'm saying the magnitude can be negative, because the triangle can be like this, the triangle can be like this. So you may get the value in negative. So that is why we have mod. So it can be 18 also, it can be minus 18 also. So we have both the options. So we have to use, or you can say we have to cater to both of these options, plus 18 also and minus 18 also. Then we have equation which is 5h minus 2k minus 19. First time we are going to take minus 18. So minus 18, 5h minus 2k minus 37 will come. When you take plus 18, you take minus 18, it's going to be minus 18. You are going to take 5h minus 2k minus 1 equals 0. So now replacing x and y with h and k, or h and k replacing with x and y. These two equations are going to come. 5x minus 2y minus 37 equals 0 and 5x minus 2y minus 1 equals 0. So the only thing which you have to understand here is the area of the triangle formula, and both 18 and minus 18 have to be taken. Then you have now you have 2 0 and minus 2 0. So find the locus of a point such that the line segment having endpoints 2 0 and minus 2 0 subtend a right angle at this point. Right angle at this point. So there is a right angle triangle. Okay. Now the point is 2 0 and this point is minus 2 0. So the angle is 90 degree. So there is a point, say this point is say P. HK point is there. HK. So these two sides or these two lines are making 90 degrees. So let us join these 2 points. So PA, PB, as I said, this is a right angle triangle. This is a right angle triangle. So we can apply the Pythagoras theorem. So we have AB square equals PA square plus PB square. PA square plus PB square. Now we know the distance formula. Nothing much has to be done. Just use this, all these distance formula you have to use for AB, PA and PB. You already know this. So let us take this AP or PA, 2 minus h whole square and 0 minus k whole square. So this one. Then now come to this one, PB. So you have minus 2 minus h whole square and 0 minus k whole square. So this you arrange, replace h and k with x and y. X square plus y square equals 4. This is going to come. X square plus y square equals 4. If A, that is minus 1 and 1, and B, 2 and 3, these are two fixed points. Find the locus of a point P such that the area of a triangle PAB equals 8 square units. So we have just done a question like this with angle as with this area as 9 units. So same questions we are doing. Two vertices are minus 1 and 1 and 2 and 3. So x1, y1, x2, y2 you can take. Then you have the third point h and k. Now this is x3, y3. Put it in this formula, area of a triangle. And as I said, we have to use the modulus. This equals 8. You have whenever you solve it, you have to take plus 16 and minus 16. So both values of 16 minus 16 has to be taken. 2x minus 3y minus 11 will come and 2x minus 3y plus 21 equals 0 will come. A rod of length L slides between two perpendicular lines between. Find the locus of the point on the rod which divides it in the ratio 1:2. So there are two things. First of all, we have to have a axis and then we have a rod. Now this rod is of length L. So this rod, there can be a partition, or there is a partition you can say, or there is a point which partition it in the ratio 1:2. So we have to use first of all this section formula, because we need that point which is between the end of these rod, so that we get that exactly point which divides it into 1:2. For that we need the endpoints. So how to get this endpoints? In order to get this endpoints, we have to draw the Cartesian coordinate system, and we have to put this L and take it and put it on the axis, and then try to find out the endpoints which will be variable, because this is sliding. This rod is not fixed, it is actually sliding. So let me show you what I am trying to suggest you. Two endpoints you need, and that point, the 1:2 partition, we need to have the endpoints. So these are two perpendicular lines, and now we are placing that rod L. So this rod L, so this is one of the instantaneous position of this rod, and this is L. Now we need to have the endpoints so that we get an idea. So only we will be able to arrive at any locus. So this will be A0, the A point, and B point will be 0B. I'm taking a point. See, it can be, you can take any point. You can take some K or LMN, it doesn't matter. And now this rod will slide more, it will come like this. So this A and B is actually variable. This will change. I'm just giving you an idea of the instantaneous position of L. Now there is a point which is dividing this into 1:2. 1:2. So whenever we have a line, we have a section formula dividing 1:2. So if we have x1, y1 and x2, y2, so if you say that this that point which is dividing is x and y, so we have the formula. What is the formula? The formula is, see, it's a section formula. So the section formula will be used like this: m x2 plus n x1 by m plus n. So m and n are 1 and 2 here, and x1 and x2 and y1 and y2 are the points 0b and a0. Or you can take alternatively also. You can take m and n as 2 and 1, and the endpoints as a0 and 0b. It depends on you how you take it, right? So this is x1, y1, x2, y2. So now you will get the value of that point hk, which is dividing it 1:2. So as I said, you will take m as 1, n as 2, and m as 2 and n as 1. So h will come as these values I just told you. Now you have the endpoints 0b and a0. You have m and n. Just put in this h. Okay, h will be the point which is dividing it 1:2. So you get 2 into a plus 1 into 0 by 2 plus 1. You will get h as 2a by 3. So a will be 3h by 2. Okay. Now in k, 2 into 0 plus b into 1 by 2 plus 1. So we have this 0 and b now you are using, and m and n as 2 and 1. So now here b will come as 3k. Now come to this triangle. This is a triangle, and it's a right angled triangle. This is a proper right angled triangle. So we'll use the Pythagoras theorem. So L square will be equals a square plus b square. L square equals a square b square plus b square. In place of a, you are going to put 3h by 2. And in place of b, you are going to put 3k. In place of a, 3h by 2, and just use it. And then finally h and k replaced by x and y. So x square by 4 plus y square equals L square by 9 is going to come. This is how we are going to do this. Find the locus of the midpoint of the portion of the line x cos alpha plus y sin alpha equals p, which is intercepted between the axes. So there is a line. Now this line is given in some form. We need to find out the x and y intercept. That is, you can directly find from the line, or I'll tell you the other method, that what is the x and y it is cutting. X and y intercept we call it. So this is a line. This line is x cos alpha plus y sin alpha equals p. So if you see, now you can these 2 points we can directly find from the equation, or there is another way. You just put y equals 0. On x-axis y will be equal to 0. So you get x equals p by cos alpha. Now coming to the other one. Now x-axis y is 0, and on y-axis x will be equal to 0. So this first point is p by cos alpha comma 0. Now here put x equals 0. Now you get y sin alpha equals p. So you have y equals p by sin alpha. Now this will be equal to 0 by p sin alpha. So this is how do you find. You can also find it by the equation as I was telling you earlier. Now divide by p, take cos alpha and sin alpha below. Now this will be equal to x by a plus y by b equals 1. Equate this. A will be p by cos alpha and b will be p sin alpha, which is actually the x-intercept and y-intercept only. These are two methods, which way you want. Now, what is the midpoint? You know what is the midpoint formula? Whenever we have 2 points, what is the midpoint? If this is x1, y1, this is x2, y2, midpoint will be Say midpoint is h and k. So x will be equal to x1 plus x2 by 2, y will be equal to y1 plus y2 by 2. So this is the midpoint. So 0 plus p by cos alpha equals h, and p by sin alpha by 0 equals k. You can use it like this, or directly you can put x also, doesn't matter. Okay, x and y. So x is, see, this is x and this is y. So now, because x1, we did this, x1 plus x2 by 2 and y2 and y1 plus y2 by 2. Now when x is p by 2 cos alpha, you can take 2 cos alpha or cos alpha on the left hand side. Since it is, the answer is showing 4x square y square, so I am taking 2 cos alpha on the left hand side and 2 sin alpha on the right hand side, and others on the right hand, on left hand side, right hand side. So now just square it. 2 cos square alpha plus 2 sin square alpha equals p by x whole square plus p by y whole square. When you add them, 4 cos square alpha plus 4 sin square alpha. So when 4 cos square and sin square cos square is 1. So this will be 4 only. So 4 equals p square by x square plus p square by y square. So when you get p square, you can take common. 1 by x square plus y square, 1 by y square. So 4 equals p square. Now take the LCM. Y square plus x square by x square y square. X square into y square. This is not plus, this is multiplication. So now take this on this left hand side. So you have 4 into 4x square y square equals p x square plus y square. So this is what needs to be proved. Now if O is the origin and Q is a variable point on y square equals x. O is the origin and Q is any variable point on this curve y square equals x. Find the locus of the midpoint of OQ. Midpoint, find the locus of the midpoint of OQ. So there is now let us make it first. So we have a curve. It can be any curve, parabola, hyperbola, or whichever curve this is. So, and the origin also is given, and we have to be sure that this point we are talking about lies on this curve. This Q lies on this curve, which is having an equation as y square equals x, right? So now let us take this Q can be anywhere in this whole curve. It can be anywhere. So we are taking just one instantaneous point. Origin is 0, 0. And this Q is what? We are taking it as A and B. You can take it as any variable. Now the midpoint is what? H comma K. So what is H? 0 plus A by 2. We did just now. And K will be what? 0 plus B by 2. So you have H equals A by 2. So A shall be equal to 2H and B will be equal to 2K. B is 2K. So now you have A and B. Now y square equals x. Now put x as a because this lie on this curve. A and B lies on this curve. So b square equals a. Now put a as 2h and b as 2k. Now just solve it and you are going to get 2k square equals h. Replace h by x and k by y. You are going to get this as the result. This is all about this exercise. Thank you so much. Take care of yourself.